is 3.3, analyzing graphs of quadratic functions. So the first kind of questions you might be given is you might have a parabola that might look something along this line. Oops, I hate that. What we're going to do is this might be my vertex, so sorry. Well, your vertex is always either at the top or the bottom of your graph. So if I had to name this point, I might actually just move everything over a little bit so it lines up. Okay, now let's go ahead and name this point. And this looks like it's at about 1/2 and probably down 2. That's going to be what my vertex is. So it's over about 1/2. Whatever my x value is at this point, that will also be what's called my axis of symmetry. So this point right here is called my vertex. My axis of symmetry will always be x equals something, and it will always actually just be whatever the x value is of our graph. And then our y-intercept will actually be whatever our c term is. So I don't actually have any numbers for this graph. Bx plus c. So this point here will be my x equals 0, comma c. So in this case, it looks like it'll be about -1.5. So I would say 0, -1.5. However you want to write 1.5 is fine. Okay, so let's actually look at an actual graph that they give us. The other thing that they actually give you is they say the max or the minimum. So in this case, this has a minimum because this is the lowest y value. So I would say minimum value is at, in this case, -2. So colon -2. So whatever my y value is. So an actual graph. Okay, so this is an example on page 257. They have the graph of f of x equals 2x minus 1 squared plus 3. So if I were to look at this graph, actually, I can look at it really quickly and tell you what my vertex is without actually looking at my graph. So my vertex is going to be +1, and make sure that it's actually whatever the sign is inside this. And my y value is 3, so it's whatever's on the outside. And we'll go over that a little bit more. I did not push those buttons. So I'm going to go over 1 up 3. And I'm going to kind of have this parabola. Okay, so I kind of remade my graph so it's a little bit better. But just looking at it, I can tell that this has a minimum. And you guys can just write min, I'm fine with that, is going to be at this value. So you'll actually have the graph from looking at this. And my axis of symmetry, I just usually write AOS, so axis of symmetry, and that will be at x equals 1. So when I actually make this axis of symmetry, sorry that my pen is doing funny things, I actually get, actually if you notice, if you look at the graph on page 257, this point goes through 5 for my y-intercept. This point over here is also equal to 5. So if you notice that they're both actually 1 unit away from the axis of symmetry, and that will happen all the way up. whatever this distance is from here to here will be the same distance there. So as I go up and up, I might have some distance up here, like way up here. This is a terrible graph. It might be 5 units away, and on the other side of this, it'll also be 5 units away. So in this case right here, it's just 1 unit away on each side. And those make really easy points to graph, and we'll talk about that in a second. Okay, so a normal graph that's in the form that looks more like this, so it might have parentheses. So not h, x minus h squared plus k. And this form will always be like y equals or f of x equals. It depends. You can see it either way. Our book uses the function notation, so you usually see f of x. There's just a few like little rules about this form. And if a is positive, this is really not an equal sign. So if a is positive, the graph opens up. So opens up, that's an opens, which means it'll look like this. If a is negative, it'll open down. And that'll look like this. Then I have if a is between 0 and 1, so all right. There's a few different ways to write it. Between 0 and 1. So I will rewrite this. A is greater than 0, and a is less than 1. I will have a really fat graph is how I think about it. So it'll be kind of like this. Whereas your normal graph will be kind of more along this side. And our normal graph that I talk about is where a actually equals 1. Okay? If a is greater than 1, so we're not talking about positives or negatives here. So I will always say less than 1 when I actually say it out loud. I really just mean between 0 and 1. And then positive and negative, we talk about it separately. If it's greater than 1, it'll be really skinny. So I just write like fat and skinny. So if you want a is greater than 1. When it's equal to 1, we just have what I think of as our normal parabola. So draw a little skinny graph. My vertex is at HK. So that's actually right in the formula. And our formula, make sure you notice that this is a negative sign. So it's always x minus whatever the actual center is. So again, this is where we're going like the opposite left and right direction that actually feels right. K, I actually go up however many I actually need to. So I'll just kind of make a little graph that says HK on it. You don't actually have to draw anything for that. And then your axis of symmetry, just from looking at your formula. And I'm going to write like a little AOS. So my axis of symmetry is x equals h. Okay, again, change whatever that sign is. Okay, and then I always have to decide if it's a max or a min. So this is always going to be k. And you will just tell me whether it's a max or a min. Okay, if you kind of visualize it, it's easiest. Or if you actually already have the graph, it's easy to look at. The method that the book uses for actually graphing it, we'll go over a couple of those. It actually involves completing the square, which we've been doing. But I think that there's an easier, kind of more intuitive way that we actually will use. We'll go through their example. So we have f of x equals x squared plus 10x plus 23. So what we actually have to do is complete the square. Remember yesterday or in the last couple days when we've been completing the square, what we've really been doing is putting this 23 on the other side. But right now we're not really going to do that. We're just going to say x squared plus 10x. And instead of adding it or subtracting it to the other side, we're just going to go over here and kind of leave a space in plus 23 just so that we don't really forget about it. We're still going to take half of 10 and square that. I'll go ahead and write this as f of x. And then I'm going to be adding that right here. So 10 divided by 2, and I'm going to square that. I'm going to add that to both sides. And see what really happens is we have this going on to both sides, but I don't really want this over here, so I'm actually going to subtract it over. So what I really end up doing is adding this, and then I'm going to subtract it, because really I can add 0 to whatever I want. It doesn't change anything. But I don't actually want to cancel it. So I will just go ahead and rewrite this so that we can actually see some terms. So I have 10x plus 5, not 5, 5 squared. And I'm going to go ahead and write that one as 5 squared, and this one is minus 25 plus 23. I like just leaving it in this term because I know right here I can factor this down to x, whatever the sign is in front of my 10, plus, and whatever number I'm actually squaring. So I have x plus 5 squared on the outside of my parentheses, and then I'm going to kind of add these things separately. I'm going to kind of do these in two pieces. Okay, negative 25 and a positive 23 is a negative 2. So I have f of x. And then I'm actually going to use this right here to factor, or to actually find my hk. So if we go back to my other page and do like all of these things, so you guys can look at that in your notes. So my hk is, I will write hk, so this is my vertex is equal to negative 5, negative 2. So if you actually notice that this has a plus 5, so I have to do whatever the opposite of that is. Okay, because that's just how that formula works when we do this. So that is my vertex. So everything asks you for the first step to find your vertex. However, I think this is a little bit more confusing than anything. It asks you then to find your axis of symmetry. In this case, it would just be negative 5, and determine whether it's a maximum or a minimum. So since this one opens up, this is kind of what my original graph would look like. Okay, because this is positive in front of this x squared. So this would be a minimum, and I would have a minimum at negative 2. Okay, and so this would be kind of what those first answers would look like. So when I actually go to graph it, I have left 5, down 2, and it's a minimum, so it looks like that. That's really all it's asking you to graph. I'm going to show you a different way to graph it, and that involves leaving it in this form, and that's why I like it, because a lot of times you will never look at this again, and completing the square is just some random thing because you're going to use your quadratic formula, and when you actually have to graph it, except for now when I'm going to make you do it by hand, you'll probably use a calculator for anything else in life that you'll ever have to actually graph these for. Okay, so this is my original equation. The first thing I'm going to do is find my axis of symmetry. So I'm going to give you an equation for that. Okay, it is going to be negative b over 2a. So this is a nice little formula to keep. I'm going to rewrite your quadratic formula up here since we're already familiar with that. And so that is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we kind of break this down, we can rewrite this whole equation as negative b over 2a plus or minus b squared minus 4ac over 2a. So how I'm going to think about this is this piece in the quadratic formula, or I can kind of isolate it like that. That is my axis of symmetry. And then my solutions will be on the left and the right hand side of that. So we will do kind of a little bit of that. So again, my first thing that I like to do is go in and write what my A, B, and C is. So A in this case is 1, B in this case is positive 10, and my C is positive 23. I don't actually have to write the pluses, but make sure if I had a subtraction sign that I am actually writing that subtraction. Okay, so negative B, my AOS, that's going to be the B part that they're asking you to find. But it's really like the first step if you're using this method. So I will have negative 10 over 2 times 1. So that means on my graph, whoops, I have negative 10 over 2. Why does it keep doing this? Okay, so I have negative 10 over 2 is going to simplify down to negative 5. So I'm going to go left 5. 1, 2, 3, 4, 5. I'm going to draw a dotted line here. And especially if you're actually drawing your graphs like I just did, please make sure that it's a dotted line. If you don't use a dotted line, I totally cannot tell the difference between the axis of symmetry, and your y axes. And it makes it really confusing to actually look at your homework. So axis of symmetry, so this would be your answer for the B part of your graphs. And then the second part that I'm going to do is find the vertex. So that's the first thing that it asks you to do, find the vertex. So what I'm going to do in this case is I'm going to plug in whatever my axis of symmetry is. So I will just do like f of AOS, hopefully. So I'm going to plug in the axis of symmetry that I got. So in this case, it'll be negative 5. So that will be negative 5 squared plus 10 times negative 5 plus 23. Okay, negative 5 squared is positive 25 minus 50 plus 23. So f of negative 5, when I actually do all those numbers, is 2. So that is negative 2. And if you kind of see some similarities here, this is where that negative 2 comes from, right here in this equation when we wrote it like this. So this is that negative 2 right here. So I'm still going to go down 2 on this graph. So I don't know if you want me to write it in a different color, and that way you can kind of see it there and kind of color code it if you want to. So this point right here is negative 5, negative 2. So now all I've done is reverse the A and B questions for like 3 through 16 is what it asks you to do. Okay, and then when I actually leave it in this form, so my original equation right here, when I have it in this form, this is my y-intercept. So in any generic form, if I have ax squared plus bx plus c, c is my y-intercept. Okay, so in this case, it's 23. So it's going to cross up here way far, so I'm going to just pretend that that is 23. And remember how the last graph that I'd asked, I told you that it was like 5 away, or 2, 4, yeah, that's 5 away. Okay, sorry about that. I'm going to go 5 the other direction. So that's 2, 4, 5. I'm going to make another point because this axis of symmetry kind of acts like a mirror. And hopefully you guys left enough room on your own graphs that you don't have to do this. And then when I actually draw my graphs, I will come down and I will make this happen right here. And this is the worst parabola ever. So that's how you can do either one of these methods. Usually I really like doing this one more. So when you are asking for help, tell me whether you completed the square. So this first one would be completing the square, or whether you found, yeah, just tell me if you're completing the square. And then some of the questions, just to look back at this graph, let me try to just drag this. Okay, so I kind of tried to move my graph. So you guys will also have to tell me the range and the intervals on which it's increasing and decreasing. So if I was asked to do the range, let me just pick something. So I have my range. Since this is at this value, you guys are pretty good at doing these in interval notation. It will be -2 is included, so I have a square bracket and I go up to infinity. Okay, so it will be my y value above and below. So if it were, just for example, if I had something like this, it would be -infinity, not -8, to, I don't know, this one looks like it's about -1 square bracket. Don't remember square bracket, so that's just one example. And then if I have to do the intervals on which it's increasing, so increasing, and you guys can totally take up more room. I'm just trying to stay on this page so I can look at the same graph without having to draw another graph and take up your time. So increasing, so it's increasing going this direction. So I'm going to say it's increasing from, not actually included at -5, from -5 to infinity. Then it asks about when it's decreasing, so it's going down here. So decreasing. And it will be happening from -infinity up to -5. Okay, and remember it's not included for increasing and decreasing. And so you'll have to do those steps as well. So probably the best example of when quadratic functions are actually used in real life is to maximize area. So the example on page 262, it has a landscaper has enough bricks to enclose a rectangular flower box below the picture window of the Jacobson's house with a 12 feet of brick wall. If the house forms one side, so this is my house, so it really is the best thing you can do to kind of draw a picture. I still always draw pictures for myself, so don't try to tell me that you're visualizing it in your head, because I don't believe you. And I have 12 feet of fencing. So all these sides together, just these 3 sides, I have 12 feet. And I want to get the most amount of area so that I can look at the most amount of pretty flowers. What dimensions will the flower box have to have? And so what I have to do is just pick a dimension, and if you want to, we might actually go through it 2 different ways. So I can call this side W. This is also side W. So if I have 12 total feet and I've taken away 2 W's, this is how much is left for here. So since I don't actually know how much W is at this point, I'm just going to say 12 minus those 2 W's. Then I will also have, and it's easiest to just give the unknown dimension to the 2 sides that are the same thing. So this actually will get used a lot. Write down all the formulas you know. So how do I find area of a rectangle? Okay, that's just length times width. And what is L in this case? So up here, I would just actually write L equals this stuff. And then I'm going to actually plug this into my formula. So my area equals 12 minus 2W, make sure you write it in parentheses, times W. I just wrote my width as width. Now I'm going to multiply that by W. So I have 12W minus 2W squared. I really like looking with my W squareds out front, so I have -2W squared plus 12W for my area formula. when I actually look at that in my graph, that's what you're going to be asked to do. I will have, whoops, I'm going to write down what my A, B, and C are. A is -2, my B is 12, and my C, since I don't have anything here, is 0. Okay, since I don't have to write it, it's just 0. So then I'm going to find my axis of symmetry. So I would have -12 over 2 times A, which is -2. So I will have -12 over -4. So my axis of symmetry is going to happen at +3. So remember that my axis of symmetry, I should have wrote it as x equals +3, and I should have an x equals all the way down, just for notation's sake. So my x in this case is actually my w. So usually we write it as x, but usually we have x's in here that are squared. So in this case, it'll even be w equals these things. So I know what my width is. That will maximize it, because if I think about it, when I am looking at a graph, so any old graph, I have some function like this. This is my axis of symmetry, which is a very sloppy parabola. We might just move my parabola over a little bit and say that that's like my maximum, and we'll call it a good parabola. So now I need to find what my actual area will be as well. Okay, because it does not just ask you for what is the width, it asks you for the dimensions. So if I go back up and through the formula that I wrote, remember I will plug in 3 to find my length. So my formula for length is 12 minus 2. Instead of w, I'm going to write 3. So I will have 12 minus 6, so my length will be 6. So my dimensions will be 3 by 6, and my area will be 18. Okay, I could also go back and plug in my area into the actual formula with my width, and I should get 18 there as well. So I'll have area equals -2 times 3 squared plus 12 times 3. You guys can evaluate that. You'll get 18. And I'm even really bad about it. Make sure you write your dimensions. So feet squared, and this is 3 feet by 6 feet. Just remember that our maximization, so this is a maximum area since that's the formula that we made, they always happen right here on this vertex. So we can pretty much find that axis of symmetry and plug it in for our vertex. So in this case, I guess our point would really be like 318. So when our length is 3 feet there, I get an area of 18 feet squared. You don't really have to write it as a formula, although it gives you that in the example. If you want to go back and look at it, you can look at the examples in the book. The hardest part is actually finding out what areas are, or what formulas are actually useful. So these are the kind of the hardest parts to write. And if you need help, I'll help you with them. Okay, for homework, I want you to do stuff on page 267. And I want you to do numbers 3 through 60 by 3s. Okay, maybe I just need to do odds because this is not very many homework problems.